Okay, so in this video I'm going to give you the English commentary to what you've been working on in class. And the topic is powers of 10. Now this means that we are raising the number 10 to a power. And in this case 10 is referred to as the base. And A is referred to as either the power or the exponent. And when A is larger than 0, what this means is multiply 10 by itself A times. So if A is 2, then 10 to the power of 2 is 10 times 10, which is of course 100. And you notice that with these ones, when A is bigger than 0, this means that we just add the number of zeros that the power says. So 10 to the power of 2, 2 zeros after the 1. 10 to the power of 5 would be 10 times itself 5 times. So it would be 1 with 1, 2, 3, 4, 5 zeros. And you can figure this out by multiplying 10 by itself 5 times, but I find it just easier to remember that the number of zeros after the 1 is the same as the power. 5, 5. For A equals 0, this is something we've looked at before in class, and I'll explain it again. So if 10 to the power of 3 is 10 times 10 times 10, 10 to the power of 2 is 10 times 10, 10 to the power of 1 would just be 10 on its own, and each time we do this, we divide by 10. Here and here. So 10 to the power of 0, we just need to divide this one by 10. 10 divided by 10 gives us 1. 10 to the power of negative 1 would give us, dividing by 10 again, 1/10. And 10 to the power of minus 2 would give us 1 over 100. And you can think of negative powers of 10. So when A is less than 0, we go to 1 over 10 to the power of the absolute value of A. So A to the minus 5, not A, sorry, to the minus 5. Let me go back. 10 to the minus 5, that's better, would be 1 over 10 to the power of 5. So the negative is like a 1 over. So we have this case when A is 0 and when A is less than 0. And we have a certain number of rules with these different exponents. So, if we have A and B are integers, then 10 to the power of A times 10 to the power of B is equal to 10 to the power of A plus B. And it's really easy to see how this works, because if we wrote this out, we'd have 10 times 10 times 10 A times 10 times 10 times 10, however many times B is, so then that's B times. And the total number of 10s we have in here, A 10s plus B 10s, all multiplied together. So how many do we have in total? Are we timesing together in total? It's A plus B. And the same way works for if we're dividing. If we have 10 to the power of A divided by 10 to the power of B, then we have 10 to the power of A minus B. And we can figure this out, that if we had A lots of 10 here, divided by B lots of 10 on the bottom, then we would be able to cancel top and bottom. So every time there was a 10 there, there was a 10 there, there was a 10 there, there was a 10 there. And we'd just be left with the 10s if there are no B's left. So this works for when A is bigger than B, because of the cancelling here. And so if we had A as being bigger than B, it might be a few more larger than B. If they matched up, then we can cancel all of these ones and we'd just be left with those, which would be the number here, take away the number here. And actually, you could see it working the other way around as well. If A were less than B, then we'd have A lots of 10 here, and B lots of 10 here. So here we have A lots, and overall we have B lots of 10. Then we could cancel each of these with each of these. We'd be left with a 1 up here. So we'd be left with 1 over 10 to the power of B minus A here. This is an equal sign, which is the same as 10 to the minus B minus A, which is the same as 10 to the power of minus B plus A, which is the same as 10 to the power of A minus B. So for A is bigger than B, and for A is less than B, and also for A is equal to B. You can do that one for yourself. So far we have two statements. We have this one here. For all A and B, we have this one here also for all A and B. And these conventions are used within science to be able to express large and small numbers. So sometimes in science we have extremely large or extremely small numbers. For example, the Earth is 93 million miles from the Sun. What does this mean? Well, I mean, it's almost a difficult number to imagine, and if you were trying to compare this distance with another really big distance, you might find it really quite difficult, because you have to then count the numbers of zeros. So for this, we have standard form. And I have the rules for standard form for you here. So, here we go. Standard form is a shorthand way of writing big and small numbers easily. And standard form always has two parts. Here we have the part. Let me draw it with the pen. That'll be easier. This part is normally known as A, and this part is normally known as 10 to the power of K. So, you can write big and small numbers easily with a number between 1 and 10, but not 10, that's multiplied by a power of 10. So here, if we wanted to convert this number, we would say, 93 million. Where would I have to put my decimal point to get a number between 1 and 10? I would need to put it here. What would I need to multiply this number by to get back to this? Well, I'd have to multiply it by 10, 100, 1,000, 5, 6, 7. I'd have to multiply it by 1 with 7 zeros behind it, or 10 to the power of 7. So 93 million is equivalent to 9.3 times 10 to the power of 7 miles. And this is the answer then in standard form. So it's always made up of a times by 10 to the k, where a is bigger than or equal to 1, but less than 10. And k can be any number. It can also be used for small numbers. If I get rid of this. If, for example, I knew that a DNA chain is really, really tiny, approximately 0.00000022 millimeters wide. Let me make that a little smaller so we can read it. I can also write this in standard form, in that I would identify that to find an A that was between 1 and 10, I would need to put the decimal point in here. But I'd need to multiply this by a very tiny number to then get the decimal point back to here. So I'd need to actually divide it by a power of 10. So 1, 2, 3, 4, 5, 6. So this would be the same as 2.2 divided by 10 to the power of 6. But of course we know that dividing by a power of 10 is exactly the same as multiplying by a negative power of 10. 2.2 times 10 to the minus 6. So this is standard form. It can also be used with the international system of units, and I'll leave that one for today because I think that's something I'd like to talk about more in class altogether, to compare the German and the English terms. To finish off this video, I'd like to give you a couple of standard form exercises. I'd like you to pause the video, try them yourself, and then I'll show you the answer in the rest of the video. Okay, so these questions here, these three, question 1 we already did, it was related to the distance between the Earth and the Sun. They all involve big numbers. So pause the video, try them yourself, and check back for the answer. So I assumed you've paused the video. Question 2 then. The decimal point's going to have to go here so that my A is between 1 and 10. So I'm going to have 3.18 multiplied by a power of 10. And that power of 10 needs to be 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 to the power of 9. Light travels at 3 times 10 to the power of 8 meters per second. This would be 3 times 10 to the power of 8 is 1 with 8 zeros on it, on the end of it. 1, 2, 3, 4, 5, 6, 7, 8. So my answer will just be 3 with 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8 meters per second. We have the same here. We have 8.19 times 1 with 10 zeros after it. So we can just move the decimal point 7 places that way. Sorry, did I say 7? I can't remember. Anyway, so we'll have 819. So the decimal point's moved twice there. 3 times, 4 times, 5 times, 6 times, 7 times. So we have then 3 there, 81,900,000 sales of Wii Sports. And then just finally, one practice question here with a small number rather than a really big number. Our standard form then will be 3.3, so that my number's between 1 and 10. Times 1, 2, 3, 4, 5, 6, 8, 9, 10. Times 10 to the minus 10 seconds. So, hopefully that's fine. If it isn't, as always, write some questions down, either in your book or to ask in class. That's absolutely fine. I'll see you at school.